Welcome to Milbank's Unmetered. I'm Ryan Skinner, VP of Growth and Revenue at Milbank. Engineering is where ideas become real, and in our industry, those decisions matter for safety, reliability, and long-term performance. Today, we are talking about how products are designed, how good ideas turn into dependable solutions, and what engineering looks like as expectations continue to rise. I'm joined by Brian Hagen, Director of Design Engineering and New Product Development at Milbank. Brian leads the teams responsible for turning concepts into products you can trust, and today we're digging into how Milbank approaches engineering, innovation, and building for the future. So Brian, how long have you been at Milbank?
I've been at Milbank going on 9 years this June.
And prior to Milbank, were you out of college? Were you working somewhere else?
Yeah, this is my first job coming out of college.
And you were Wichita?
Wichita State University. Yep.
And you're from Wichita?
I am from Wichita.
So how in the world do you end up at Milbank Manufacturing in Kansas City, Missouri?
Well, when I came out of college, the engineering market was really competitive. So it's kind of apply everywhere you can and see where you stick. And Milbank was one of my first interviews, and it went really well, and came up here from Wichita.
So prior to coming to Milbank, what did you know about a meter socket?
Pretty much nothing, other than it being that gray box on the side of your house that gives you power.
So I'm just a simple salesperson, and I do not think like an engineer. But, when I go to sell something, I need to have like a certain amount of interest in it, right? I need to have like a little passion behind it to successfully sell something. It seems like in engineering, you're able to, transition from one product to another. From an industry standpoint, it doesn't really matter. Where does an engineer, do you have to have that same amount of desire, or is it just kind of as long as you can come up with a concept, you go for it?
I think when you get into the new product development side of the world, you have to have that passion to be able to drive that growth and that innovation. From a day-to-day perspective, transition from industry to industry is pretty easy because the work, although might change from industry to industry, is all kind of the same content.
So at Milbank, obviously we're metering enclosures, power distribution and controls. What part of Milbank interests you the most from just a engineering, not even just a new product development or new design engineering, but just an engineering basic? What of our product categories interest you the most?
Power distribution and controls is that up and coming market for us at Milbank. It's exciting. It's new. That's where right now the biggest innovation is happening for Milbank.
So I guess to go back, you graduate college, everything's competitive. You end up hearing about this company in Kansas City, Missouri. You relocate to Kansas City, I guess.
Yeah.
So maybe go through just your career, where you started to where you are today at Milbank.
Yeah. So when I first started, I was in ME1. I came in, I worked on sustaining engineering mostly for that first year and a half. I was identified pretty early on by management that I probably had some new product development skills and ETO or engineer to order development skills. So I got transitioned over into that kind of role for the next year and a half. From there, I moved up to strictly new product development with a focus on innovation. I did that for a few years. And then when power distribution and controls, Power Advance kicked off for Milbank, I came over as the engineering manager there to help kind of lead that innovation in that sector of the company.
So today, when you're in the middle of designing it or your team's designing a new product, what engineering principles matter most to you?
For me, it's safety. Our products are extremely long-term installations. We're talking 20, 30 years life cycle, if not longer, for our products. And designing a product that's safe for that long term is the most important thing that we look for when we design products. And after that, we talk about user interaction and manufacturability. How do we make it the most efficient, cost-effective product for both us and the customer?
So when we kind of look around, a lot of the big Fortune 500 companies, the big up and coming tech companies, those are all mostly ran by engineers, right? Think of Elon Musk and, Bill Gates, and you go on and on and on. All the AI companies. Are there any that you look up to in that sector?
I mean, Elon Musk, I think from an engineering perspective, has a lot of really powerful ideas on how to build efficiencies in product and just design ideas in general. I like to follow that kind of stuff, but so does Jeff Bezos. I mean, if you look at Blue Origin and the stuff he's kind of demonstrated with that company, there's a lot of those big innovators out there that can really help make decisions for myself.
So you talked about, safety being one of the principles that matter most. And obviously Milbank, I mean, we're designing projects and we're selling products to customers who are mostly utility, right? And one unique thing about our product is utilities are touching our product and the end user or contractor is touching our product. So, and utilities are obviously very concerned about safety. How do we design products that uniquely can have safety features for both a contractor and a utility? Is that a thought that goes into the design of products?
Yeah, absolutely. I mean, our biggest thing, we design UL approved product. So the UL regulations and standards kind of help lead us down the path of what's acceptable in terms of safety, both for the customer and user, as well as the utilities. And then, as you mentioned, utilities are a big specifier of this product. They have their own expectations of what safety is for their linemen. And on top of that, I grew up working on cars and doing different things. I have that mindset of, if I had to put my hands in this product, would it be efficient for me to work with? Would I feel safe using this product? So that kind of all goes into it.
So how often are we making changes to product today based on just feedback from utilities and contractors, maybe saying, hey, here's a safer way to do it, or hey, here's a design feature we'd like to see? Do you get a lot of input from end users and utilities, or does it mostly come through the sales team, or how does that end up working?
Voice of customer is huge on the changes we make. The sales team brings in engineer to order opportunities all the time with new unique aspects and new unique requirements. NEC is always changing, trying to drive some more safety into our product. But all the innovation that has happened at Milbank since I've been here has been driven through voice of the customer, our actual end user saying, hey, if you do this a little different, it's going to help us in the long run be able to install these quicker and safer.
So one interesting thing for me, is just kind of how much the electrical industry, how slow it is to change, and also how much it's changing, right? I mean, I think 10 years ago, I think people would be kind of laughing about, data centers, like, what are you talking about? And EV car charging, and some of the places that it's going or has been. What are things from maybe even going back before your career, going back into college and growing up, and I'm sure you had an interest in engineering, obviously, before you went to college, but what are some of the things in the electrical industry that have kind of taken you by surprise, or, maybe excite you about where it's going in the future?
I think what excites me is the fact that we're going to product that is focused on, I mean, I go back to safety. That's a huge thing, right? 10 years ago, Milbank's bread and butter was that U7040, single position meter socket, sold it all day. And over the last 5 years, the market has shifted and continues to shift to the meter combo business, which is safety focused. And if you look back over the last 30, 40 years across engineering and across product design, safety has always been what drives that change, as well as efficiencies. How fast can you install it? How fast can you build it? So,
yeah, kind of that labor shortage out there, and how much can we?
Yeah, lack of technical knowledge in the labor force right now.
Where do you think, we're at that connection point between the utility and the homeowner, right? And that's kind of what Milbank is in the simplest way. I mean, we're the cash register for the utility, or that demarcation point for the utility. There's always going to be, as long as there's a utility and as long as there's a homeowner or a business owner, there's going to be some sort of demarcation point, right? But I guess thinking big picture, one of the things that the government was talking about just a few weeks ago was, some of these nuclear reactors and having their own power plants for some of these data centers. And, just curious what your point of view on that is. Like, do you see that being in the future? If you're thinking 50 years from now, will I have a powered generator at the side of my house and that's where I get my power from? Or, do you have any insights for us non-engineers here?
I definitely think there's going to be a transition in the market over the next even 10 to 15 years to more of a microgrid type setup for homes. When you start looking at the demand for EV charging data centers, there's a huge spike in energy demand, and which you're seeing through demand rate billing and time rate billing, that kind of thing. So I think what I'm looking at from a change in the market is battery backups. Mainly, how do we consume energy at a consistent rate in our home and then have it stored when we have those demands to help kind of flatten that curve and also lessen the load on the grid.
Yeah, and we kind of see that now from our customer base, right? We're seeing more microgrid type of opportunities and more projects that we're involved in with some of that. But to your point, it does drive me nuts during the summer when the local utility here is surging their prices, and I drive my electric car home and it's completely full of battery because I got to charge during the day when it was low rates, and I can't have my own microgrid and take power out of my car and use it to run my dishwasher and my oven. And that drives me nuts.
Yeah.
And it's like, how do we get to a place where I can take that power, use it, and then overnight when costs go back down, recharge my car, right? So to your point, that would be great. How do we get there as soon as possible?
Right. And that's the way the market's moving. All the modern EVs that are slowly going to where they can backfeed your home. The chargers that provide that power in your house have to have that capability to sync phases and that kind of thing. But it's definitely the direction I see demand going residentially. And even, you talk about data centers, right? They're building their own generation facilities right off. So if they can't get enough power from the grid, they're going to develop it themselves. So
if you're a contractor today, doing your installations and maybe you're commercial, maybe you're residential, how much different is your job? From somebody like you who's designing future products, right? And always, thinking about that next best thing, how much are their jobs going to look different in the next 10, 15, 20 years, right? I assume with some of this new technology that's coming out, their jobs will look different.
Oh, absolutely. It's going to go from a pretty standard install nowadays with a meter socket, a disconnect, and a load center with all your power distribution for your house to installing batteries, installing an inverter, possibly solar panels, a generator. All that stuff's going to slowly get included in a typical residential install. So it's going to go from a small work content to a large work content. And then our focus as Milbank is, if we stay in that meter socket realm, how do we make our products interface with those other products as easy as possible and not have to complicate the installer's job any more than necessary?
So when we're thinking of, an electrical engineer or mechanical engineer, or just, I guess, any of the different types of engineers, how does AI play a part in the future, I guess, of those trades? I assume AI is probably not going to take over, installing, a meter socket on the side of a house, but how does AI help engineering with some of these new innovations? How can AI be a partner?
We're starting to see AI help with design optimization. So you present AI a concept and it'll help you optimize material based on loads and paths and those kind of things. It's also starting to play a huge part in the engineering side with drawing creation. That's really where I'm seeing it right now from our end of things. I think there's a ton of potential, though, to help with design optimization, configurations, those type of obstacles that we face that are a huge labor suck for engineering. I think that's where AI is going to have the biggest bang, is how do we take the monotonous, inefficient steps that engineering has to go through today and make them quick.
Yeah, I would agree with you. I mean, I think that's, from a sales perspective, from a customer service or from a quotation side of things, I mean, you're able to take this large data set, and instead of having to manually go through it, you can throw it in there and say, hey, look for this and give me this, right? And
Right.
it speeds that up. That's really where we're seeing it. And there's obviously all the agents and everything that go into the ERP systems, and everybody has an agent, and it'll be interesting to see what ends up happening. I mean, I think at this point, AI has been very helpful, but I'm kind of just curious what ends up coming from it. I don't think anybody knows. If somebody knew, they probably wouldn't be sitting in this room right now.
Right. Yeah.
If you were in college today, and you were, getting in, same career path, what would be the industry that you would want to be in?
I mean, if I had to start all over, I always had a huge interest in space and technology. I mean, you brought up Elon Musk and Jeff Bezos and all of that.
And you're from Wichita, which is, I mean, that's
aerospace capital of the world for a long time. Yeah. Aerospace was a huge part. I loved rockets and spaceships and all those kind of things. But also looking back, I don't think I would change the path that I've been on. So I've really enjoyed working for Milbank and the things that I've gotten to do here, the innovations that I've been a part of. It's been a huge part of my life.
But yeah, I mean, if you could design a spaceship, that'd be pretty cool, right?
It'd be really cool, but the hours that go into that also aren't cool. So, yeah. I mean, those guys are working 50, 60 hours a week, years on years.
Yeah.
So,
well, it's exciting. It's, I mean, one thing that fascinates me about just engineering is being able to make something from nothing, and, with that being said, I mean, how do you, how do you know when a concept or an idea that maybe you've, designed up in the computer, and how do you know when it's ready? How do you know when it's ready to, for me as a simple salesperson, right? I'm always like, how do we know that's ready to go on the side of a house? Or how do we know that's ready to be energized? So how do you go from concept to production to, putting a product out there on the system?
Yeah, I mean, our biggest thing we do is UL, right? Almost everything we design and build is UL listed. We'll get to, so we review those as standards. We design based on those standards. And then once we get to a point where we're comfortable with it from an engineering standpoint, we meet with our manufacturing and sales teams and make sure they are comfortable with the path that the design is going. But then we submit it to UL, and UL reviews it based on their standards. They prescribe testing that we need to do, whether that be heat testing, cycle testing, rain testing for environmental ratings. And then once it passes that, that's typically when Milbank says, hey, this is ready to go.
So what is one thing that you would like for people to understand about how Milbank approaches engineering and designs?
I mean, it goes back to safety. We value our quality reputation almost above anything else. Our goal is to give that end user the best quality and safest product we possibly can, as well as, I mean, Milbank goes out of their way in many facets to make sure that the customer is getting exactly what they're asking for. That's one of the things we're known for, is we'll customize anything or design anything for anybody to a certain extent. And you can see it with our breadth of product and how many customers actually come to us for custom work.
No, I assume, I mean, it's from your point of view, I mean, it's more than, from the sales team, we're always thinking about like, how do we make the customer, the contractor, the utility, like make their life easier and put the best product out there and solve some sort of issue that they are having through the benefits of our product, right? You kind of have two customers you're serving, right? You have the external customer, but then I would also assume that you have to make a product that is not crazy hard to manufacture. So maybe how does that come into this, right? I mean, how do we make it where, it can flow through a factory?
I mean, it's a huge part of it. One of my main focuses over the last few years developing Power Advances. How do we develop these high amperage products, but still make it easy for manufacturing to put these things together quickly. The industry has changed considerably over the last 15, 20 years when it comes to this aspect of design. And that's partly because the workforce that we have and is across the country right now is less technical. So the ability to put more complicated stuff together is kind of diminishing. So there needs to be a huge focus on making it repetitive and easy and efficient. So when we go and look at a new product design for a customer, if it's anywhere close to high volume, our focus is how do we make it super fast and simple for production to get through, whether that be new molded parts, new pieces of sheet metal, new tooling. Yeah, we got to look at all that.
So when you think of, some of the products, and obviously can't share everything you guys are working on, but, is there anything that you guys that you're working on that you'd like to share that you're super excited about? What do you guys are all doing all that super sneaky stuff over in the engineer building. So I'm always trying to find out exactly what you guys are working on.
From a power advance standpoint, we're developing some new enclosures. Wall units are going to be coming out here before too long on the PVA, our high, big capacity, high amperage product that we have. We're going to start releasing some wall units for that. So wall adjacent, single-sided. PVB, our smaller version, is also getting that same treatment with some wall units. And then we're also working on a PVC line, not to be confused with the conduit that we all use, but it's a mid-range design that kind of fits that gap between our 200 to 400 amp product that we design right now, our CP2, CP3Bs, and in between that PVB. So a little more distribution space, also CT rated sockets, self-contained rated sockets will all fit into that product. And then on the metering enclosure side, we're redeveloping our 400 amp meter mains that we have to be a little more efficient, a little safer, getting away from wire and getting more bus in that product to help some cost efficiencies. And then conduit hubs that we've developed some twist lock conduit adapters years ago, and through some of the market challenges we've had, that kind of got put on pause, and we're getting back to developing that and working on how do we get that into the field. And then we have some insulation piercing connectors that we're also working on that kind of hit the same roadblocks as the conduit adapter. And with that's going to be a shear bolt so that the customers using those impacts out there can just run the impact down and not have to worry about torquing it. It's going to give them the right connection right off the bat.
No, it sounds like some really exciting stuff, and I'm always fascinated with the stuff that comes out of engineering. With that said, I mean, Brian, is there anything that I'm missing? Are there any final thoughts that you'd like to, provide both our internal and external audience here at Milbank?
No, just that engineering, I mean, our main focus is how do we support our customers both internally and externally. That's always been Milbank's goal, is supporting those linemen out there, those electricians out there that are installing our product. How do we design product the best for them? And as well as how do we give production the most efficient products to build, the safest products to build. That's Milbank's main focus. That's engineering's main focus, and it'll continue to be.
Well, Brian, I really appreciate you coming on the Unmetered podcast today. If you have any questions out there on Milbank and Milbank products, please reach out to our website, milbankworks.com. Send any of us an email. We'd be happy to get back out to answer those questions for you. Please like and subscribe this podcast, and we'll see you next time.
Thank you for listening to the Unmetered podcast presented by Milbank. Unmetered is hosted by Ryan Skinner and executive produced and edited by Sean McElvain, supported by the Milbank manufacturing marketing team. Make sure to follow us wherever you listen to your favorite podcast. The Milbank podcast and all related content are provided for general informational and educational purposes only. The content is intended to share information about Milbank products, industry trends, and related topics, and should not be construed as professional engineering, technical, electrical, safety, or installation advice. Always consult qualified professionals and refer to applicable codes, standards, and manufacturer specifications before selecting, installing, or using any products.